Last time we talked about a multiplicative identity, which is the quantity that when you multiply it by something, it yields the original result. So for numbers, when we multiply, say, 5 by the identity, it should yield 5. And we mentioned that for all numbers, the multiplicative identity is the number 1. We also learned last time, through sort of a process of working through that matrices also have multiplicative identities. And the idea is the same. You multiply a matrix by the identity and you get the original. So we talked about the things that make an identity what it is. So this is a 2 by 3. We'd want to get a 2 by 3. The inside dimensions would have to match. So this would have to be a 3. And the outside dimensions would give me the answer, so this would have to be a 3. We talked about last time that all identity matrices are square. And then through that process of sort of working through the matrices, we found out that the identity is not only square, it has 1s on the main diagonal, which goes from top left to bottom right, and 0s everywhere else. Now, while I'm writing this out, that's everywhere else. You could check this on your calculator and actually multiply this matrix by this matrix, and it should give you the same matrix back. If you want to do that, pause the video and do so. What I want to talk about now, though, is something called multiplicative inverse. So a multiplicative inverse, I'll, again, go over it with numbers first and then talk about how it looks with matrices. So with a multiplicative inverse, you are multiplying an original value times the inverse, and that yields the identity. So multiplicative inverse is what you multiply an original value by to get the identity. So let's look at an example with numbers. So if I were to say, I want to find the multiplicative inverse of 8, when I multiply it by its inverse, whatever that is, I should get the multiplicative identity, which we just talked about on the last screen, is 1. So what number would you have to multiply 8 by to get 1? That's right, 1/8. Now, one of the things we talk about with multiplicative inverses of numbers is that they are often called reciprocals. Multiplicative inverse and reciprocal, when you're talking about numbers, are the same thing. There is a symbol for a multiplicative inverse. If I want the multiplicative inverse of 8, I could actually write that as 8 to the negative first. Now, if you were to pull your calculator out and do 8 to the negative first, it would give you 1/8, which is the multiplicative inverse of that number. Now, that symbol is going to be really important. The fact that that means an inverse, it'll come up over and over and over again over the course of this class. Now, when it means inverse, it doesn't always mean reciprocal. So it means multiplicative inverse, which for numbers is the same thing, but isn't the truth for all other things. Now, for today, what I want you to know is that your calculator can find inverses of matrices for you, but you're also going to be expected to find inverses of small matrices yourselves by hand so you know what's going on. So let me explain to you really quickly. Let me add a screen here. How the matrices thing works. So multiplicative inverses for matrices. Now, the first thing you need to know, and we'll talk about this a little bit later this week, is that only square matrices have inverses. So if you have a 2 by 3 or a 3 by 2 and you try to do something with an inverse in your calculator would give you an error. And you can try it and see what error it gives you, but you can't find the inverse of a matrix that isn't square. So if you want to find an inverse on your calculator, you enter the matrix. And you should remember how to do that. Go to the matrix menu, edit, give it dimensions, and then quit out. But if I want to find the inverse of this, I would take this matrix and then put the inverse symbol on it. Now on your calculator, that's x to the negative first. It looks like a negative first power. It really means the inverse of this matrix. So this would be the inverse matrix of 5, 4, 3, 2. So when you do this, it's going to give you a matrix that has a bunch of decimals in it. If your calculator has the capacity to switch to fractions and you remember how to do that, go ahead and do it. If you don't remember how to do it, I'll show you in class on Tuesday. Now, the idea is if I were to take this inverse matrix and multiply it by the original, I should get my identity matrix. So go ahead and test that on the calculator. See if this times this gives you this. All right, now, this is going to be super useful for us. We're solving a system of equations. So I'm going to give you a system of equations here. Let's see, let's make that 17 and, nope, not a 3. And let's make that 13. So this is a system of equations. I'm going to rewrite this as a matrix equation, and then I'm going to use what I just found about inverse matrices to solve this system. So here we go. First of all, I'm going to write it as a matrix equation. So matrix equation has a coefficient matrix times a variable matrix and that equals a solution matrix. So this is coefficients. By the way, it's really important that your equations be in standard form here. Variable matrix, solution matrix. Now, this is an equation that if I could divide both sides by that coefficient matrix, I would have the variable matrix by itself. Well, I can't divide by a matrix except by multiplying by its inverse. So what I'm going to do here is find the inverse of that coefficient matrix and multiply both sides. Now, one of the things you have to remember, matrix multiplication oh my gosh, wow, is not commutative. Meaning you can't just switch the order around in matrix multiplication because you won't get the same result. So when I find the inverse of this coefficient matrix, in order for it to cancel out with the coefficient matrix, I would have to multiply it on the left. I'm going to have to do that on both sides. Now, I'm going to show that simply by writing this. When I write the inverse, it's going to have to go to the left of this matrix on the right-hand side. Now, if I were to multiply this out using my calculator, I believe that's going to give me a matrix that looks like this, 3, 1. Try it out, see if it does. Now, that means the solution to this is x is 3 and y is 1, because these two matrices are equal to each other. They have the same dimensions, corresponding elements have to be equal. So I'm going to give you another system and ask you to solve it using your calculator, but this one's going to be a bigger system. And actually, I'll walk you through this one just so you can see how the setup goes. So this is a bigger system. It's a 3 by 3. So I'm going to start by writing it as a matrix equation, coefficient matrix, times the variable matrix equals the solution matrix. And I want to multiply both sides by the inverse of that coefficient matrix to make it go away. So it has to be done on the left, and that multiplied by the inverse will cancel out the coefficient matrix on the left-hand side. So essentially it's going to look like this. And when I do that multiplication in my calculator, again, I'm not asking you to do this by hand, do it in your calculator, that result will give me something that looks like this. Check and make sure that's right, and then proceed. So basically, this gives me the solution to the system. It's -2, 5, and 3. Now, you can see the advantage of this over all the substitution or elimination way is that there's so much like tiny arithmetic errors you can avoid, and your calculator is doing a large majority of the work. So what I'm going to ask you to do for homework and for the rest of class is to go ahead and do a few of these solving by matrix equations on your own.